Here's an easier example because it's merely a polynomial. So you know its end behavior is the same as the end behavior of the first leading monomial. We know the end behavior is as such. Now for everything else, right now what I'm really interested is you identifying whether or not I have a local max or local min, and maybe where you can find inflection points, discuss concavity. So maybe just for this day, I'm going a little too far in graphing. I just think I can go a little far in graphing because my first couple examples are so basic. So it is a polynomial. To find out whether it's a positive or negative, above or below the x-axis, we can factor. Build a sign graph. So I think it's pretty clear graphically speaking. I look like this. Now, I'm not the best, so technically speaking, there should be symmetry with respect to the y-axis. But for me to find these local mins and local maxes, I will take this opportunity to differentiate. And factor. And continue to factor. Build myself a sign graph. Plot these three zeros. But these three real numbers subdivide the real number line into 4 subintervals. And if I check them, here's clearly what I get. That means the original function changed from decrease and increase and decrease and increase at about those 3 values of x. So at negative 1 over root 2, as well as at positive 1 over root 2, I do yield a local min. And the local min y value specifically is 1/2. No, 1/4 minus 1/2. So negative 1/4. And I have a local max at x equals 0, but the local max specifically is a corresponding y value. That is 0 as well. So it looks to be like I changed concavity maybe here and here. So to find those inflection points, let's dive in and differentiate again. So at least the x-coordinates of the inflection points are located negative 1 over root 6 and positive 1 over root 6. I'll leave the question marks for you. You can check them by putting into the original function's output. And by the way, I should have built my sign graph. These two zeros subdivide the real number line into 3 subintervals, and when I check them, I am viewing this, meaning the original function changed from concave up to concave down to concave up, and clearly here are the 2 inflection points.